Hello students, this is a continuation of our recording in which we learned to write linear equations, and now this is doing the applications. So we have I think 2 or 3 examples here for this recording. It says a local hardware store charges $28 to rent a carpet cleaning machine for 24 hours. In other words, $28 a day. And then $10.98 for each medium-sized bottle of shampoo. Okay, so it's $28 a day. $28 per day, and then $10.98 for each bottle. Okay, write a linear function that represents the cost of renting the machine for X days, and then 2 bottles of shampoo. Okay, so the cost to rent the machine is the price per day, $28 per day. So $28 per day, remember when you see the word per, that's when you're going to multiply it times x. So $28 per day will be 28x. So 28x plus the cost of the shampoo. So we're going to buy 2 bottles of shampoo. And so at 2 bottles, you've got 2 bottles of shampoo, and it's $10.98 each. So it's just shy of $20. So 2 times $10.98 is $21.96. So this is how much the soap costs you. So the cost to rent the machine is $28 per day plus $21.96 because you bought 2 bottles of shampoo. Write the linear function as s. Alright, so they're going to want me to make this s. And then if they want me to write it as a function, since I'm using the variable x, I really should put s of x equals 28x plus $21.96 for the shampoo. Evaluate s of 2 and interpret the meaning of this. Okay, so if I have to evaluate s of 2, and I know my equation is s of x, then 2 is referring to my x value. So if x equals 2, and x is my number of days, then this means how much is it going to cost to rent this machine for 2 days? Okay, so go to my formula. S of x we determined was 28x plus $21.96. So 2 is replacing my x, so this is 28 times 2 plus $21.96. So this is going to be what? 56 plus $21.96, which will be $77.96 to rent the machine for 2 days, owning and having purchased 2 bottles of soap. Okay. A linear cost function. This is part 2. A linear cost function models the cost to produce x items. C of x is mx plus b. M is the variable that represents the cost per item, and b is the fixed cost. Example. The cost to make lemonade is 8 cents per paper cup and $25 for the lemonade. Here's the word per. So this is something times x. So 8 cents is 0.08 cents times x, where x is the number of cups. Then you pay $25 for the lemonade. So your cost, which they're calling C of x, which normally I would just say C equals, but your cost is 8 cents per cup plus 25 cents for the lemonade, for $25 for the lemonade. The revenue function, here comes the revenue function, models the revenue for selling the items. And it's P times X, where P is the price of the item. What is the revenue for selling lemonade at 25 cents per cup? Okay, so act like you've got your lemonade stand up and ready. Your lemonade is there. You poured it through the cups, and now you want to know how much money you're going to make when you sell it. Okay, so your revenue, which they're going to want in function notation, your revenue is 25 cents per cup. 25 cents for every cup you sell. The profit function is, profit is your revenue minus your cost. Your revenue is the money people give you when they buy your product or they buy your lemonade, minus your cost is your expense in your cups and your, the actual lemonade itself. So our profit function equals our revenue minus our cost. So our profit, and they're going to want me to put this in function notation, our profit, we're going to call it P of X, is our revenue, which we said is 0.25x minus our cost, and this should be a C, minus our cost. And our cost is 0.08x plus 25. Now, it's not just minus 0.08x, it's minus the entire function, which is the 0.08x plus 25, so you need to put that in parentheses or square brackets. So our profit is 0.25x minus 0.08x minus 25. So this becomes, if you take your 0.25 minus your 0.08, because you can combine those, you're going to get 0.17x minus 25. This is your profit function. So you have a cost function, you have a revenue function, and then you have profit. Alina is starting a summer business power washing home driveways and sidewalks. She will charge $35 to pressure clean a driveway and the sidewalk in front of the house. Her startup costs include her initial purchase of the power washer for $330, and then she'll have a fee of $2 per house she must pay to the homeowners for the use of the water for each house. Okay. Write the linear cost function. Okay, what is her cost to start this business? Okay, her cost is the power washer, the price to buy the power washer, and then it's $2 per home. Because she's got to pay to use the water. It's $2 per home. So it's going to be 2 times X. When you use the word per, it's going to be 2 times your variable, and we try to always use X. So X is the number of homes. There's the cost. And if we put it in function notation, instead of saying C equals, we will use C of X. Write a linear revenue function for power washing X homes. Okay, her revenue is how much money the homeowners are going to pay her. So it says that she's going to charge, up here, she's going to charge $35 to pressure wash their home, not their home, their sidewalk and their driveway. So her revenue is $35 per home for 35x. What is her profit function? Well, that's the easiest part. The profit is going to be the revenue minus the cost. So the profit in function notation is her revenue, which is 35x, minus cost, which is 330 minus 2x. So her profit is going to be 35x minus 330 plus 2x when you distribute this minus sign. So one more time, her profit is 35x plus 2x, which is 37x minus 330. There it is. Okay. How much profit, meaning use the profit function, will Alina make if she power washes 15 homes? Remember, X equals the number of homes. So we need to go to this profit function and replace X with 15. Okay, so this is going to be 37 times 15, which turns out to be 555. So her profit will be $225. For power washing 15 homes. So she's already, at this point, she's already paid for the power washer and the soap, and her profit is $225 in her pocket. How many homes must only need a power wash to make $330? Okay, this says if her profit is $330, how many homes must she power wash? Okay, so our profit function is 37x minus 330. The profit, the p-value, let's change that. That's not a good number. Let's make that 300, I don't know, 350, because I don't like having the two numbers the same in the equation. Her profit is $350. Okay, so for her profit to be $350, then you would solve for x, which is the number of homes. So I'm going to add 330 to each side of this equation. So that becomes what? 680 equaling 37x. And then continuing to solve, you would divide by 37. So you would definitely pick up your calculator here. 680 divided by 37. Uh-oh, I have a daughter home. Just a second. Okay, so 680 divided by 37 is 18.378, blah, 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 blah. Now remember, we're looking for number of homes, so I guess I would round that up and say 19 homes to kind of overshoot the value. And that's how you work these applications with profit, revenue, and cost.